Hi, today's lesson is on rate of change and slope. Make sure you include your title on your title page in the table of contents. And make sure to write down the objective, vocabulary, and complete the do now. Today we're going to be talking about how to identify rates of change and slopes and how to relate a constant rate of change to the slope of a line. So if you look down at now, you're going to determine the x and y intercepts of the following equation, 2x minus 5y equals 20. Notice that this equation is in standard form. Please also describe the correlation shown in the scatter plot. Don't forget that we always look at our graphs from left to right. Okay, let's go on to the next idea. So rate of change is a ratio. It compares an amount of change in the dependent variable. The dependent, again, is the y value, to the amount of change in the independent variable, which, again, is usually the x values. So if you think of independent like time being graphed along the x value and how something happens over time or a change over time in a line graph is the y value. If you'd like to go ahead and make a screenshot of this page and print and add this into your notes. Otherwise, please copy it into your notes. So if you look at how we use this information, the table below shows you months, 2, 3, 5, 7, 8, and different temperatures. Again, time is always going to be independent. So if we're identifying the dependent and independent variables, it's easy with this one. The independent is the month and the dependent is the time. I'm sorry, the temperature. So we would graph these along the x and we would graph these values on the y. So you please determine the rates of change here. So again, if we're doing a rate of change, we look back, we want the change in the dependent variable as a ratio compared to the change in the independent variable. So my rate of change in the dependent variable from 56 to 56, did that change at all? No. So we can see that from 2 to 3, month 2 to 3, the change in the temperature was 0. The change in the month was, from month 2 to 3, was 1 month. And so it was 0 because 0 divided by 1 is 0. From month 3 to 5, that's a change in 2, right? You have 2 here. And the change in temperature was 7. If you notice, we're always going from the second value to the first. So from 3 to 2, we subtracted 56 to 56, and in this case, 63 to 56. We want to make sure that we're going in the correct direction. So that's a change of 3.5. So from 5 to 7, again, that's a change of 2. And the temperature changed 8 degrees in that time. And the last one is the change 1 over 1. So it's a change of 1 month and 1 degree. So if we want to find out when the greatest temperature rate change was, from month 5 to month 7, we can look at that. And between month 5 and month 7, the temperature changed the greatest amount. It had the most steep change here. So this table shows the balance of a bank account on different days of the month. The rate of change is what you're looking for, and you're looking for when the balance decreased at the greatest rate. So we can look at the days up here. They're increasing, but as you notice, the balance is decreasing. So we are going to look at two possibilities. Our independent is the day. Again, that's a time. And our balance depends on which day. And from the first day to the sixth day, it was a decrease of 53, because that's 265 over 5. The next one, a change of negative 75 over 10, or negative 7.5 per day. From day 16 to 22, it didn't change at all, so that was a 0 decrease. And the last one was about 4.375 per day. So when was the greatest decrease? Well, it looks like from the 1st to the 6th, that was our biggest decrease. So that shows us the rate of change, how fast something is going up or down. In this case, it quickly dropped. We can see that in the table here. It quickly dropped from day 1 to day 6. So how we use that and look at it as well as a way we can graph it. So this was our first chart. This was the months with the temperature. And if we want to graph and show the rate of change, we're going to do the ordered pairs first. And an ordered pair would be written as 2, 56 because the month is the x value and the temperature is the y value. So we have our ordered pairs. We can graph our ordered pairs. You see over here we had 2, 56 and again 3, 56, 5, 63, 7, 71, 8, 72. Those are our ordered pairs. And if we look at the change, no change, huge change, even bigger change, and a very small change. So we see that between months 2 and 3, they didn't change at all. And the segment is actually horizontal. And that's a very interesting thing. The zero slope, if you know it's not going anywhere, that's a horizontal line. So if we want to talk about the connectedness and making a straight line, if all of the connected segments have the same rate of change, so if we think back to what we talked about linear functions, that the constant change in x and a constant change in y, if all of the connected segments have the same rate of change and they have the same steepness, they're going to form a straight line. And that constant rate of change is called the slope of the line. And we do determine it by finding the change in the y over the change in the x. So please take a minute to go ahead and make a screenshot of this graphic and paste this into your notes. So how do we determine slope? Well, we can look at it if we have it graphed, and we can see that if we start over here from left to right, we have the ordered pair -6, 5. Down here we have 3, 2, and we're going down 3 and over 9. So that's down a negative amount and then a positive to the right 9. And that simplifies to 1/3. So if I looked at that, if I went down 1 and over 3, notice that that point is on the line. Down 1 and over 3, that point is on the line. Down 1 over 3, that point is on the line. And it does say that you can go either way, but because we're talking about graphs usually from left to right, I would prefer that you start from the left, go ahead and go down 3 and to the right. That's also going to show you that the slope is in fact negative. If you look at the line is going from left to right, it's going down. And so we have -3 over 9, and that makes a lot of sense for us. So if we want to figure out the slope here of 0, -3, which is the point right here, and 5, -5, 5, -5, point right there, we can look at this line and decide what to do. So please try to determine the slope by looking at the 2 ordered pairs and determining how far down you go before you go to the right. Awesome. The slope is in fact -2 over 5 because you go down 2 and over 5. Well done. So when we look at horizontal and vertical lines, they have a different kind of slope. In fact, our vertical line, when we know it does not pass the vertical line test, it's not a function, it's called an undefined slope because you can't divide by 0. It doesn't create a function. If you remember back into our, again, talking about just regular functions. So it's not a linear function and it has an undefined slope. That's this line here, our vertical line. If we look at the horizontal line, It does move from left to right. It passes the vertical line test, but it's not going up or down. So this is called a zero slope. So a horizontal line has a zero slope and a vertical line is fine. If you want to copy and paste this into your notes, you may, or please make sure that you note that the horizontal line has a zero slope and a vertical line, the slope is undefined. So this is definitely something I want you to copy and paste in your notes just so you can have this graphic for yourself. This is, again, left to right, this is positive. Left to right, this is negative. The zero slope is a horizontal line, and the undefined slope is a vertical line. So you can just look at them. You don't even need to calculate the slope to determine if it's positive or negative, zero or undefined. So if I look at these, just to describe them, the one on the left, the slope is, yes, this is a positive slope. And the one on the right is, you're correct, again, it's a negative slope. What about the one on the left here? The vertical line is correct, undefined. And this is a line going from left to right, and it is, yep, the line is positive. So if we want to compare slopes, we can talk about the slope of a line and how it compares to another slope. And if I'm looking at the blue line here, if you notice it goes up 4 and over 1, so the slope is 4. And this one goes up 1 and over 2, so the slope is 1 over 2. And we can say this line with the slope of 4 is much steeper than the line with the slope of 1/2. And we actually compare them as absolute values. So 4 is greater than 1/2, so that has a much steeper slope. Again, the one with the 2 and the 1, again, since we're doing absolute value, even though that's negative, the slope -2 is steeper than the slope of -1. And here, because -3, the absolute value is greater than 3/4, even though this is negative, it is a steeper slope. So we can compare slopes that way. So finally, the last thing I want you to do is go ahead and complete the lesson quiz, and we will go over this tomorrow in class. Take care.